All right. So in the previous videos, we have talked about the reciprocal identities. We mentioned one quotient identity. So let's make sure that we know all of the identities that we need. So the big quotient identity is the one that ties tangent together with sine and cosine. So tangent is the quotient of sine and cosine. Well, if you remember that cotangent is the reciprocal of tangent, that means that if I want to use sine and cosine, I would just do the reciprocal of what I see here. So cotangent can be rewritten as cosine over sine. Okay, so you got to know these guys. In addition to those, we also have some other key ones, the Pythagorean identities. There's one guy you absolutely have to know. So that if you forget the others, you can always build from there. So the main one says that sine squared plus cosine squared is equal to 1. Now, I do want to make sure we understand that, yes, this is the Pythagorean identity, but you may also see this rewritten as where it's, say, solved for sine squared, which would make that 1 minus cosine squared. It's just another way to write that, just like you could have cosine squared is equal to 1 minus sine squared. It's an equation, it's a formula, so if you need to manipulate that to have it in terms of one piece versus another, you can do that, and it doesn't change the meaning. The other ones that we see will relate tangent to secant. So tangent squared plus 1 is equal to secant squared, and 1 plus cotangent squared is equal to cosecant squared. Now, I've written tangent squared plus 1. You could say that's 1 plus tangent squared. It doesn't matter because it's a sum. And you could always say, you know what, I have tangent squared. I want to rewrite tangent squared. Okay. You can rewrite tangent squared by subtracting 1 to the other side. And you can say tangent squared is secant squared minus 1. That's totally fine. But you absolutely have to know these. You have to know the reciprocal identities, or else we can't even do most of the stuff that we're going to come across. All right, so now that we have those, let's take a look at this example. So suppose I have a triangle. That's going to be good enough, right? Here is some angle measure. Let's call that theta. And we have side lengths for the triangle as being 4 and 5, and we have one side that's unknown. Now for this, I want us to come up with the trigonometric function value for all 6 functions, right? So again, if you happen to forget, I would definitely make sure that you start off with knowing SOHCAHTOA. Okay, write that down at the top of every page. SOHCAHTOA, you see it, you know how to build things. For example, if I want to do sine, so the sine of this angle measure is O and H, so that means the opposite over the hypotenuse. Or, as we've already seen, that's y over r if we were on a circle, right? All right, so here, our opposite side is going to be 4. But what about the hypotenuse? Well, we don't have the hypotenuse, but we do know the Pythagorean theorem. So the Pythagorean theorem would say that our hypotenuse squared should equal 5 squared plus 4 squared. All right, so that's 25 plus 16, which equals 41. Thus, my hypotenuse should be the square root of 41 when I take the square root of both sides to get the hypotenuse by itself. So the sine is opposite over hypotenuse, 4 over the square root of 40. Square root of 41. We want to rationalize this, make it look a little bit nicer. So that's 4 square roots of 41 over 41. All right, that's one function down. Well, what about cosine? Cosine, again, using their little acronym here, A over H. So that would be the adjacent side over the hypotenuse. So the adjacent side is 5. The hypotenuse we already figured out was square root of 41. Again, rationalize your denominator. So this becomes 5 square roots of 41 over 41. There's my cosine. All right. Next, let's find tangent. SOHCAHTOA. O and A, that's opposite over adjacent. So in my diagram, I see the opposite is 4, adjacent is 5. This is one of the easiest things we've ever done. It's just 4 over 5. All right, so far so good. But we still have 3 other values to find. So I'm going to scroll this down a little bit. We still need to find what is the cosecant, the secant, and the cotangent. Now, cosecant, if you recall, is the reciprocal of sine. So even though I write 1 over sine of theta, we need to make sure we understand that that notation just means you do the reciprocal of sine, right? So I see what sine is, and I could take this and I could flip that over. Or I could go back one step and look at that. Because if I do the reciprocal of this piece, I just have the square root of 41 over 4, and that guy's done. There's no rationalizing that has to happen. Similarly, when I take secant, as long as I remember that is the reciprocal of cosine, I look at the work that I did for cosine. Cosine at one point was 5 over the square root. So if I take the reciprocal now, at that point, we have the square root of 41 over 5. No need to do any rationalizing. Because if I had started here with this one, I would have to do the reciprocal first, which puts a square root in the denominator, and then I have to rationalize that. So I don't want to do extra work if I don't have to. And finally, the cotangent is supposed to be the reciprocal of our tangent. So if I look at tangent as 4 over 5, flip it over, we get 5 over 4. And very, very quickly, we are, well, as the kids would say, we're donezo, right? All right, so let's try a different kind of problem. Suppose we were given the following. We were given that the secant of theta is equal to negative 7 halves, and our theta is in quadrant 3. Theta is in quadrant 3. Now, the way we want to do this is that we want to draw a diagram. This is really the easiest way to do the problem. We have some angle measure that's coming all the way over here, and the terminal side is down in quadrant 3. Okay. Now we can just put our theta here as a reference angle because of how it's associated, and it's going to be totally fine. When we draw our triangle, we always want to make sure that we drop the perpendicular to the x-axis, never to the y-axis. Now, this is what my secant is. And I don't know about you, but I feel like I always have to put it back into cosine form so I can make sure I totally understand what's going on. So if this is the case, that means that the cosine, which is the reciprocal of secant, is going to be negative 2 over 7. And as we've mentioned before, I'll say it again, SOHCAHTOA. So we're talking about cosine and how it is adjacent over hypotenuse. So they're telling me what the adjacent side is and what the hypotenuse is. So the adjacent side is 2, the hypotenuse is 7. Now keep in mind that we are in quadrant 3. And there is a negative that they have here for secant slash cosine. The radius, the hypotenuse, we're always going to keep that guy positive in these diagrams. But it's going to be a negative for the x value, right? Always pay attention to your signs. All right, we just need to find the y value here. And again, this is a Pythagorean theorem question. So I have negative 2 squared plus y squared is equal to 7 squared. So 4 plus y squared equals 49. Y squared equals 45. And y is going to equal the square root of 45, which we want to make sure we do simplify and reduce. So this guy breaks down as 9 times 5. So the y value is 3 square roots of 5. But keep in mind that we are underneath the x-axis, so this actually means negative 3 square roots of 5. Now, if you're the kind of person that oftentimes misses your signs, you need to make sure that you are highlighting your signs so that you don't miss them. Because we need to know those signs so that we can accurately come up with the other 5 trigonometric function values. Okay, so I'm just going to erase the work that I have right here. Okay, we already have that y value. All right, so, oh wait, we already have cosine. That's cool. Now let's do sine. So sine is supposed to be opposite negative 3 square roots of 5 divided by the hypotenuse. That's the so part right here. Opposite over hypotenuse. And then tangent is opposite negative 3 square roots of 5 over adjacent negative 2. And again, pay attention to your signs. Negative divided by negative is going to turn this into a positive value, which, as you will recall, I hope, all students take calculus. So we're in quadrant 3, and as such, being in quadrant 3, only tangent and his reciprocal will be positive. Everything else is going to be negative. Secant is negative, so his reciprocal is also negative. That guy right there. Sine is negative, which means his reciprocal, cosecant, will also be negative. So we need to do the reciprocal of this, which makes that 7 over 3 square roots of 5. Rationalizing here, we just need a square root of 5 factor in the numerator and denominator. And this gives us negative 7 square roots of 5 over 15. These two guys right here, we're going to give us just a factor of 5. And then we have, from tangent, we're going to come up with cotangent. So that's going to be the reciprocal of this guy right here. So that's going to be 2 over 3 square roots of 5. Again, rationalize. And we have 2 square roots of 5 over 15. So we've found all of the other trigonometric function values. That's 4 right there. There's the guy that we found at the very beginning, cosine. And so, totally done. So remember, SOHCAHTOA. Remember, all students take calculus. That way you get the right signs, you get the right ratios, the right relationships for these for the sides of the triangles, and everything's going to be fine.